today we're going to talk about trigonometric functions of any angle. So the question is, how can we find the trigonometric ratio of any angle? So let theta be an angle in standard position, and let the point P of x comma y be any point on the terminal side of theta. Let r equal the distance from the origin. So just like we have this picture over here. So we know that this point that we have, that's the point we are going over x and up y. And so we know that to find r, this is a right triangle, so x squared plus y squared equals r squared. So r would be equal to the square root of x squared plus y squared as long as it's not equal to 0. And here theta is, of course, going to be this distance from here to here. And if we want to find the sine of theta, remember our SOHCAHTOA. So that means that sine is the opposite over hypotenuse. So sine is equal to the opposite of theta is y, and the hypotenuse is r. So y over r. Cosine is equal to the adjacent over hypotenuse. So the adjacent is x from theta, and the hypotenuse is r. So x over r. And tangent is equal to opposite over adjacent. So y over x. Now, if we're talking about the unit circle, that means r would be equal to a value of 1. So if r is equal to 1, then that's where we get y over r would be y over 1. So that's where we say that the sine of theta is equal to y. And here, this would be x over 1, so that's where we got the x coordinate is the cosine of theta. So that's where those points came from that we talked about last year. So the cosine of theta, comma, the sine of theta is another way to find that coordinate ordered pair right there. And that means tangent would then be the sine of theta over the cosine of theta. The cosecant function is the reciprocal function for sine. Secant is reciprocal of cosine. And the cotangent is reciprocal of the tangent. So if cosecant is reciprocal of sine, then the reciprocal of y over r would be r over y, or 1 over y, because remember we're saying r is equal to 1 because it's a unit circle. So that means that's equal to 1 over the sine of theta. Secant would then be the reciprocal of cosine, which would be r over x, which is equal to 1 over x, which is equal to 1 over the cosine of theta. So secant theta equals 1 over cosine. So that means cotangent would be equal to the cosine of theta over the sine of theta. So make sure you know each of these different reciprocal functions and which ones they go reciprocal with. Notice that the cosecant with the c in front is reciprocal of sine with the s in front, because a lot of times students try to put cosecant and cosine together. They don't go together, so secant and cosine, cotangent and tangent. And one other thing I want to mention that we'll talk about later, but if we know that the cotangent is cosine over sine, we can also rewrite this as being equal to the reciprocal of tangent, which is 1 over the tangent of theta. So those are also equal to each other. It's an identity that we'll talk about later. So note that point P can be any point on the terminal side of the angle except for the origin, since different choices for P generate similar triangles. Thus, the values of a trigonometric ratio depend only on the angle. So we always want to make the angle with the x-axis. So that's important. You don't ever want to make your triangle angle with the y-axis. It's always going to be using the x-axis. So let's say that we want to let this point 6, 8, and 3, 4 be a point on the terminal side of theta. We want to find the sine, cosine, and tangent of theta. So let's go ahead and start off with the smaller length. So we're saying this point is an x value of 3 and a y value of 4. So over 3 and up 4 to get to this point. So if we want to find the sine, cosine, and tangent, we also need to figure out then what the radius is equal to. So the radius we know is going to be the square root of x squared plus y squared. When we do that, we get 16 plus 9, which is the square root of 25, which ends up being equal to 5. So the sine of theta is equal to opposite, which is 4 over the hypotenuse, so 4/5. The cosine of theta is equal to adjacent over the hypotenuse, and the tangent of theta is equal to opposite over the adjacent. So now let's go ahead and look at the point 6, 8. So I'm just going to highlight that triangle so we can draw over it. So here's the triangle for 6, 8. So first we need to find now the radius, or r. So r is equal to the square root of 6 squared plus 8 squared. So 64 plus 36 gives us 100, and the square root of 100 is 10. So that means r for this one is equal to 10 for the blue triangle. So now we want the sine of theta. So the sine of the angle, now we're using this as 6 for the x and the y as 8. So opposite over hypotenuse would be 8 over 10, but of course we can reduce that. So when you reduce, that becomes 4/5. The cosine of the angle is equal to adjacent over hypotenuse, which reduces into 3/5. And the tangent of the angle is equal to opposite over adjacent, which reduces into 4/3. So notice that these values that we just got are the same as the ones that we got for the other values. So that shows you that it doesn't matter what the radius length is because the trigonometric values are going to reduce. That's why we like using the unit circle, because those values are always going to give you the same values on the unit circle when you reduce them. Something else that we can look at, if we actually wanted to figure out what the angle was equal to, we could. Remember, you can use sine inverse, cosine inverse, or tangent inverse. So if we actually use our calculator, remember, if I want to solve for the angle, I have to use the sine inverse. So if I want to do the sine inverse, so second sine, that gives me the sine inverse of the trig ratio, 4/5, would give me the angle of theta. So notice that it gave me a decimal, so that means that I know that I'm not in the correct mode. So you always want to check your mode on your calculator because it always defaults to radians. So we need degrees. So if I do that again, now I should get the degree measure, which is 53.13 degrees. So even if I were to do the cosine inverse and use that trig ratio, which was 3/5, notice I also get 53.13 degrees. And if I do the tangent inverse of 4/3, I would also get the same answer. So using those trig values. So notice that with the same angle, even though our value was different, we still are getting the same trig ratios for sine, cosine, and tangent. So the angle theta is 53.13 degrees. We didn't have to find that, I'm just letting you know. All right, so for the next one, it says, for example, we want to find the sine, cosine, and tangent of angle theta whose terminal side passes through the point -3, -2. So the first thing you should do is draw your point. And so my point is in the third quadrant because we have -x and -y. So we have -1, 2, 3, and -2, which would be somewhere about here. So that point right there. So if I draw my triangle, it would be right here. So we have -3 and -2. Now we need to find our r value. So remember, to find r, r is equal to, we're just doing the Pythagorean theorem, so negative 3 squared plus negative 2 squared. So r is equal to the square root of 13. And now we need to find our sine, cosine, and tangent of the angle. So the sine of the angle is equal to opposite, so negative 2 over the square root of 13. And keep in mind that your hypotenuse will always be a positive value. You shouldn't ever have a negative hypotenuse. So then for this, we need to fix this problem because we don't like to have radicals in the denominator, so we need to rationalize by multiplying by the square root of 13 over the square root of 13. So that gives us negative 2 root 13 over 13. So that is the sine of theta. The cosine of theta is equal to negative 3 over the square root of 13. So again, we need to rationalize by multiplying by root 13 over the square root of 13. And that gives us negative 3 root 13 over 13 for the cosine. And the last one we have is the tangent of theta is equal to opposite over adjacent. And so negative over negative becomes positive. So that means the tangent of theta is equal to 2/3. So now we're going to go ahead and find the 6 trigonometric functions of the angle of theta whose terminal side passes through the points 2 and 1. So again, we want to draw a triangle. We know that we are in the fourth quadrant because we have a positive x and a negative y. So this would be 2 and negative 1, and this would be our angle of theta. So theta is always made with the x-axis and the terminal side, never the y-axis. Just keep that in mind. So for this, we want to find r, which is the hypotenuse. So r is equal to the square root of 2 squared plus negative 1 squared, which is the square root of 5. And now I want to find the 6th trigonometric function. So that means we want to find the sine, cosine, tangent, and then the reciprocal functions, cosecant, secant, and cotangent. So the sine of theta is equal to opposite over hypotenuse. And of course, we don't want to leave our answer like that, so I'm going to multiply that by root 5 over the square root of 5 to rationalize. And when I do, I get negative root 5 over 5. So that is the sine. The cosine of theta would be equal to adjacent over the hypotenuse, so 2 over root 5. Rationalize that. And we get 2 root 5 over 5. And now I need the tangent of theta. So opposite over adjacent would be negative 1/2. Now we want to find the reciprocal of each of these. So the reciprocal of sine is cosecant, so CSC of theta. So if we're doing the reciprocal, we're going to flip our fraction. It's a lot easier if you reflip what our first part of our answer without the rationalizing the denominator, because if you do that, then you get root 5 over negative 1, which is just equal to negative root 5. It's a lot faster to do that than if you flip what we did here, then you'd have to rationalize the denominator again, which is fine, it just takes longer. So it's just easier to use your first answer. So the reciprocal of cosine is the secant of theta. So again, I'm going to use this right here to flip, because then I don't have to worry about rationalizing the denominator again. So root 5 over 2. And then the reciprocal of tangent is cotangent of theta. And so the reciprocal of negative 1/2 would be negative 2 over 1, or just negative 2. Okay, so let's go to the next part. On the next part, if we look at this unit circle here, we've already talked about the tangent values, but let's go ahead and look at them again. So remember that the tangent of theta is equal to the sine of theta over the cosine of theta. So we've already talked about how to get these in the first quadrant on the last video that we had. So here we know sine over cosine would be 0 over 1, so this is 0. At 30 degrees, sine over cosine, so the tangent of 30 degrees would be, again, sine over the cosine, which is root 3 over 2. So when we simplify that, when you divide a fraction by a fraction, you multiply by the reciprocal of what's in the denominator, so that becomes 2 over root 3. And then, of course, you would want to rationalize that by multiplying by root 3 over root 3. So the tangent of 30 degrees is equal to root 3 over 3. And then here, if you have root 2 over 2 divided by root 2 over 2, that's just equal to 1. Here, if you were to divide root 3 over 2 by 1/2, you end up with root 3. And here we have sine over cosine. 1 over 0 is undefined. So just reminding you what we did in the last video. So if we think about the signs in each of the quadrants, we know this one is always positive here because we have both x and y are positive. Here, x is negative and y is positive. In quadrant 3, we have negative comma negative for x and y. And in quadrant 4, we have a positive x and a negative y. So because of that, all trig functions are going to be positive in the first quadrant: sine, cosine, tangent, and all the reciprocals. When we get into the second quadrant, notice again that our x value is negative. So since our x value is negative, that means that in this quadrant, our signs are going to be positive, but everything else is going to be negative. So I'll move that over. So negative, positive. So this would be S. In the third quadrant, notice that it's negative, negative. So sine and cosine are both negative. But if you divide the two for tangent, because tangent sine over cosine, tangent would be positive in this quadrant. And in the fourth quadrant, notice that your x is positive and your y is negative, so cosine is positive here. So we actually say that all students take calculus. So in the first quadrant, everything is positive. In the second quadrant, sine and also its reciprocal are positive. And then tangent and cotangent in the third quadrant, and cosine and secant in the fourth quadrant. It's good to know that because it helps us when we solve trig functions or trig equations later. Go ahead and do some examples. We've already done some of this before, so maybe see if you can pause the video and do these on your own, and then when you're done, you can unpause the video and we will check your work. So looking at the first one, we want to find the exact values of sine, cosine, and tangent of 9 pi over 4. So we know that 9 pi over 4, if we look back at our unit circle, well, I don't see 9 pi over 4, but it's over 4, which means it is coterminal with a value on our unit circle, but we have to find it. So since it's over 2 pi, that means we are going to subtract 2 pi in order to figure out where it's at. So when I subtract 2 pi, I need a common denominator. So we have 9 pi over 4 minus, and what's common between 4 and 1? Well, 4, so that means I need to multiply the second fraction by 4 over 4. And when I do that, I get 9 pi over 4 minus 8 pi over 4, because that's the same thing as 2 pi. And that gives me that 9 pi over 4 minus 8 pi over 4 is pi over 4. So that means that the sine of 9 pi over 4 is coterminal with pi over 4, so that means it's going to give me the same answer as the sine of pi over 4. So without looking at your unit circle, what's the sine of pi over 4? Well, it's in quadrant 1, so root 2 over 2. For the next one, cosine of 9 pi over 4 would be coterminal with the cosine of pi over 4, which is also in the first quadrant, and root 2 over 2. And tangent sine over cosine in the first quadrant is equal to 1. Looking at the next part, we have the sine of negative pi over 3. So negative pi over 3, you can go backwards on your unit circle, or you can add 2 pi to figure out where the positive angle measurement would be that's on your unit circle. So if I add 2 pi here, that means to get the common denominator, I'm going to multiply this by 3 over 3. So that gives me negative pi over 3 plus 6 pi over 3, which is equal to 5 pi over 3. So that means the sign of negative pi over 3 is coterminal with 5 pi over 3. So if we find the sign of 5 pi over 3, I know that's going to be equal to that same value. So what quadrant is 5 pi over 3? And take a minute to see if you can think of that on your own. So we know that 5 pi over 3 is right down here in the fourth quadrant, and we're looking for the sign. So the sign is the y-coordinate, which is negative root 3 over 2. So that means this is equal to negative root 3 over 2. So again, if you now see if you can do the other problems on your own. So 19 pi over 6 is over 6. I know it's on my unit circle. I need to subtract 2 pi because it's gone around the circle more than once. So that means I need a common denominator. So if I multiply this by 6 over 6, that's going to give me 19 pi over 6 minus 12 pi over 6, because 12 divided by 6 is 2. That's the same thing as 2 pi. So 19 pi over 6 minus 12 pi over 6 is 7 pi over 6. So that means that 19 pi over 6 is coterminal with 7 pi over 6. So the cosine of 7 pi over 6 and 19 pi over 6 have the same value. So you have to think, where on my unit circle do I get 7 pi over 6? So we know 7 pi over 6 is in quadrant 3, and the cosine is the x-coordinate, so negative root 3 over 2. Looking at the next one, we have the secant of 17 pi over 6. So 17 pi over 6, if I take that value and I'm going to subtract 2 pi, so that means I'm subtracting, again, 17 pi over 6 minus 12 pi over 6, because if I multiply by 6 over 6 on that fraction, I get a common denominator. So that gives me 5 pi over 6. So I know that the secant is reciprocal for cosine. So I actually have to write this as 1 over the cosine of 5 pi over 6. So if I know the cosine is 5 pi over 6, I have to find that value. So we have to think, where is the cosine 5 pi over 6? So 5 pi over 6 is in quadrant 2. The cosine is the x-coordinate, so negative root 3 over 2. So this is 1 over negative root 3 over 2. Of course, we don't like to have fraction divided by fraction, so I need to simplify that by multiplying by the reciprocal of what's in the denominator. So 2 over negative root 3. And that gives us 2 over negative root 3 when we multiply by the 1. Of course, we want to rationalize that by multiplying by root 3 over root 3, which gives us 2 root 3 over negative 3. So that is our solution, negative 2 root 3 over 3. For the tangent, we know that sine over cosine, so we have negative 11 pi over 4. So we're going to go ahead and take the negative 11 pi over 4. Since it's negative, we want to figure out the positive value in between 0 and 2 pi that it belongs to, so we're going to add now 2 pi. So if I add 2 pi, that means I need to multiply this by 4 over 4 to get a common denominator, so that would become 8 pi over 4, because 8 divided by 4 is 2, that gives us 2 pi. So when I do that, I get negative 3 pi over 4, which means it's still not from 0 to 2 pi, so I want to add another 8 pi over 4. And when I do that, I get 5 pi over 4. So that means the tangent of negative 11 pi over 4 is coterminal with the tangent of 5 pi over 4, so it'll give us the same trig values. And if we go back up to our circle, remember that 5 pi over 4 is right here. What's the tangent? The tangent is equal to 1. And so that means that the tangent of negative 11 pi over 4 is equal to 1. So for the next one, we have 405 degrees, which is over 360. So 405 degrees minus 360 degrees gives us 45 degrees. So that means the cosine of 405 is coterminal with the cosine of 45 degrees, which is in quadrant 1, which we know is equal to root 2 over 2. It's the x-coordinate. Looking at the cosecant of 4 pi over 3, 4 pi over 3 we know is on our unit circle, so again we know this is in quadrant 3. So cosecant is reciprocal for sine, so 1 over the sine of 4 pi over 3 will give us the same answer. So the sine of 4 pi over 3 we know is in quadrant 3, as we said. And so we know this would be 1 divided by, so if you don't remember your unit circle, here is 4 pi over 3. The sine is negative root 3 over 2. So if we have a fraction divided by fraction, multiply by the reciprocal, so really we're just multiplying by the reciprocal of what's here. So that becomes 2 over negative root 3, rationalize the denominator, and we get negative 2 root 3 over 3. So that's what the cosine of 4 pi over 3 is equal to. Tangent of negative 390, so since it's not in between 0 and 2 pi, we need to add 360 to make it so that it is. So when we add 360, we get negative 30 degrees. That means we need to add another 360 degrees so that it's in between 0 and 2 pi. That gives us 330 degrees. So the tangent of 330 degrees, which is in quadrant 4, gives us our solution. And we know from our unit circle that's in quadrant 4, the tangent of 330 is negative root 3 over 3. That's why it's important to make sure you know your unit circle values and can recall them quickly, because when we do problems like this, if you don't know your unit circle well, it takes even longer to do these. So negative 120, we want to add 360 degrees in order to get our value in our unit circle, which is 240 degrees. So the cosine of 240 degrees is coterminal with negative 120 degrees. And when we do the cosine, that's the x-coordinate on our unit circle, which is negative 1/2. So next we're going to talk about reference angle theta prime. So for an angle theta in standard position, the reference angle theta prime is a positive acute angle formed by the terminal side of theta in the shortest angular distance to the x-axis. So remember, it has to be a positive acute angle, and you're always using the x-axis. So in the first quadrant, if you're in between 0 and 360, then your theta prime is going to be this same angle, theta prime equals theta. If you're in quadrant 2, then theta prime is going to be this angle right here. Notice we haven't gone past 180, so we know this is 180 degrees. And we know this is 270 degrees and 360 degrees and 90 degrees. So since we haven't gone past 180, that's why it's 180 minus theta, or pi minus theta if we're using radians. So in the next quadrant, when we're in quadrant 3, the shortest angular distance to x-axis and positive acute angle would be this right here. So theta prime is theta minus 180, because now we've gone past 180. And in the fourth quadrant, it would be this angle right here for theta prime, so 360 minus pi, or 2 pi minus theta. So if theta is negative or greater than 360, first find the coterminal angle, then find the reference angle. So always make sure it's in between 0 and 360. So now if I use those rules for these problems right here, if theta is equal to 125 degrees, we know that we are in quadrant 2. So this is the angle measurement of theta, but we know that theta, the reference angle theta prime, is the shortest angular distance to the x-axis, and it has to be a positive acute angle, so that's going to be this angle right here for theta prime. So theta prime would be equal to 180 degrees minus theta, which is minus 125. So that means theta prime is equal to 55 degrees for our reference angle. So here, negative 323 is not in between 0 and 2 pi, just like we said up here. So if we add 360 degrees to that, we get 37 degrees. So here's my angle. Negative 323 would be this angle right here. And so theta prime is this angle, which is 37 degrees. 7 pi over 5 is going to be in quadrant 3. If you don't know, you can always figure out the degree measure. So remember to find the degree measure, 7 pi over 5. You multiply this by 180 over pi, which gives us 252 degrees. So that can tell you what quadrant you're in. So then for here, this is the angle measurement of theta, but our reference angle is the positive acute angle formed by the terminal side and the shortest angular distance to the x-axis, which would be right here. So theta prime, since we're in this quadrant, that means we take the angle, which is 7 pi over 5, and we're going to subtract it from 180, or because we're using radians, we're subtracting pi. We need a common denominator, so you're going to multiply this by 5 over 5 to get that common denominator. So 7 pi over 5 minus 5 pi over 5 gives us theta prime being equal to 2 pi over 5. See if you can do the next one on your own. So 11 pi over 18 is 110 degrees. So we know it's going to be in quadrant 2. So this is theta. And so we want to find this angle over here for theta prime. So theta prime is equal to, and we're using radians, so we're going to do pi minus 11 pi over 18. So that means we need to multiply this by 18 over 18 to get a common denominator. So when I do that, theta prime is equal to 7 pi over 18. We can also use these for values in our unit circle. So if we have 5 pi over 4, we know that's in quadrant 3 on our unit circle. So since we're in quadrant 3, theta prime would be equal to 5 pi over 4 minus pi. So if we get a common denominator by multiplying this by 4 over 4, that gives us pi over 4. Which makes sense because 5 pi over 4 was using that 45-degree angle for the triangle, so pi over 4. So 5 pi over 3 we know is in quadrant 4. So theta prime is equal to 2 pi minus 5 pi over 3, which is equal to pi over 3. And again, I just skipped the step of getting the common denominator, so I multiply this by 3 over 3 to get the common denominator. So 6 pi over 3 minus 5 pi over 3 is pi over 3, in case you were wondering. And over here, we know this is in quadrant 2, so theta prime is equal to pi minus 5 pi over 6. So when I get my common denominator, multiply this by 6 over 6, and theta prime is equal to pi over 6. It's the same concept as how we got all the special right triangles in each of the different quadrants and why they were same, except you just switch the signs. It's kind of the same concept. You were using the reference angle in order to help you find that, which is something that we also talked about last year in Math 3. And that's it.